adding and subtracting like terms. So in our first video for algebra, we came across that x plus x equals 2x. We found that pattern when you add the same number with itself, you get double that same number that we had at the start. And this is actually the secret to algebra, because in our last video we saw if there's no coefficient, no number out the front, it really means 1. So we're saying 1x plus 1x equals 2x. Well, that looks like all we did there was took those ones and added them together to get 2, and that's essentially all it is. So if we have 4x plus x, that's going to be 5x. Because those pronumerals were the same, and this one's coefficient was 1, and 4 plus 1 gives us 5. What about 10x plus 2x? That's just 12x. What about 20x minus 5x? That's just 15x. What about 7x minus 10x? That's minus 3x. So we can get negative terms as well, because when we have 7 and minus 10, we get minus 3. What about x minus 2x? Well, that's actually minus x. And the reason that is because we have 1 minus 2. And 1 minus 2 is minus 1, so that's why it's minus 1. Remember, we just don't write the 1 out the front of our pronumeral. What about a plus a? That's just 2a. Because remember, no coefficient out the front means it's 1. 1 plus 1 is 2. 2b plus 3b. Well, that's 5b. Minus 3c minus 4c. It's minus 7c. So you just got to be careful here, because we have minus 3 and we're subtracting another 4, which means we end up on minus 7. So just following our integer rules there. What about 2c minus 4c? Well, that's 6c, because remember from your integer rules, the double negative actually equals the positive. We can change it. What about x plus y? That actually equals x plus y. Well, why can't we add these two together? Well, that's because they're not like terms. We can only add and subtract like terms with each other. So this is x, this is y, they can't be added. So our answer is x plus y. So what's a plus b? Well, that's just a plus b, because again, they're not like terms, and we can't add them together. xy plus xy. Well, that's 2xy. So here, even if we have more than one pronumeral, they still are one term each, and their coefficients are not there, so it means they're 1, and 1 plus 1 gives us 2. What about xy plus yx? Well, that's 2xy. Okay, why can we add those together? Well, in algebra, it doesn't matter the order in which the terms are written as long as they're multiplied, because as we know, 2 times 3 is 6, and 3 times 2 is also 6. So when we multiply, it doesn't matter about the order in which we multiply. So x times y is the same thing as y times x. So these are like terms, their coefficients are both 1, and that's how we get 2xy. What about 7abc plus 2 B, C, A. Well, that's 9A, B, C. So we can add these together because we've got A times B times C, A times B times C. They're not in the same order, but they are like terms, and we can just add the coefficients together. 7 plus 2 gives 9. And it's important to note that when you write your final answer, you want to try and write your pronumerals in alphabetical order. That's just a common thing that we do in maths. Let's have a look at another one. 4x plus 2y plus 2x. Well, that equals 6x plus 2y. So here, I was able to add the x's together, the 4x and the 2x, to give 6x, but I could not add the y term to it because it's not a like term with the x's. What about 2x plus 3x plus 5? Well, the answer to this is 5x plus 5. So again, I can add the x terms together because they're like, but I can't add the number by itself because it's not a like term. So numbers by themselves are only like terms with other numbers by themselves. Let's look at 2x plus 4y minus x plus y. Now, to do this one, when there's a lot of terms, it can get a bit tricky. So sometimes it helps us to put boxes or circles around the terms to see which ones are like. And we have to make sure we include the sign on the left of the term, or in front of it. When there's nothing in front at the front, it just means it's positive. So the term that's like with with 2x is this minus x. So see, I'm including the term in front of it on the left. And the positive 4y is like this positive y here. So we can match up the colors to know we can add with each other. So 2x minus x, well, 2 minus 1 is 1. So we're left with 1x, and we can just write x because we don't have to write the 1. And then positive 4y plus y gives us positive 5y. What about a squared plus a squared? Well, that's just 2a squared. Because they're like terms, because they both have a squared. Their coefficients are 1. 1 plus 1 gives us 2. What about 4x cubed plus 6x cubed? Well, that's 10x cubed. So as long as the powers are the same, x cubed, we just add the coefficients together and we get 10x cubed. What about 3x squared y plus 4x squared y? Well, that's 7x squared y. So even if there's multiple pronumerals, as long as each one's power is the same, we can add them together. So the x is squared, we have a y and a y, so they match up. So that means they can be added, and 3 plus 4 is 7. And we just keep the pronumerals the same. What about 4x squared y plus 2yx squared? Well, that's 6x squared y. And the reason we can add these together is that we have an x squared and an x squared, a y and a y. They're out of order, but remember, this is just multiplication and it doesn't matter in which the order we write the terms inside. So they're like, and we add them together to get 6x squared y. We just like to write it in alphabetical order. X comes before y in the alphabet. Let's look at 3x squared y plus 2x y squared. Well, that's just 3x squared y plus 2x y squared. I couldn't have these together because the x was squared over here, but not here, and the y squared here, and not here. So even if just one of those didn't match up, I wouldn't be able to do it. What about 2a squared b squared c squared plus 4a squared b squared c squared plus 6a squared b squared c squared? Well, that's just 12a squared b squared c squared. So sometimes it can look a little ugly, but it's actually pretty easy. So they're all like terms. A's are all squared, b's are all squared, c's are all squared. So we just add 6 plus 4 is 10, plus 2 is 12. And we just keep the polynomials the same. So even if it looks a little ugly, sometimes it's actually pretty easy. Let's look at one more tricky one. 3mn plus 2n plus 3 plus 6n squared plus 7nm minus 2n squared plus 3m squared n minus 1 plus minus 7mn squared. Alright, that was long, but if we understand this one, we'll understand most things. So let's box up all our like terms. So here we've got a term with m and n, and there's another one with m and n, only one of each. And remember, we're collecting the sign in front as well. So here's a term with just n, collecting the sign in front, and there's no other ones with just n. Alright, this is a number by itself, plus 3, and this minus 1 is a number by itself. Also, we can actually change our double sign over here, plus minus, into a minus. So let's do that now. That's the same thing as a minus. Okay, let's keep going, collecting our like terms. So we've got an n squared term here, and an n squared term here. What about, we have an m squared n term, where m is squared and n isn't, but over here, n is squared and m isn't, so it's not a like term with this one. So that's a term on its own. Don't have any more colors, but we'll just put a circle around this one. Okay, so now we can add the like terms together since we've identified what's a like term. Might do them with the color that we've got. So let's add our blue ones together. So 3mn and 7nm is going to be 10mn, because we like writing them in alphabetical order. Alright, we can add our green one in next, because it's not a like term with any of them, as we can see from the colors. Plus 3 minus 1, well, that's just plus 2. So that writes in next. Let's do yellow. So we've got 6n squared minus 2n squared gives us plus 4n squared, because 6 minus 2 gives us 4. We can write in our 3m squared n term next, because it's not a like term with any of them. And then our blue term on the end, minus 7mn squared, because it's not like with any of the others as well.